guys, today we are going to look at some real-world problems that you can solve using quadratic functions, quadratic relationships. So remember, when I say quadratic, that means you're going to see like an x squared involved, okay? So a really common place in which we see this is anything that involves vertical motion. If I take something and I toss it up, because what goes up must come down. Or I could actually throw it down as well, and that downward speed with which I throw it could affect things. Or I could just like drop an object and let it fall on its own. And there's an equation that we can use to model situations like this. Anything that's affected by gravity and movement can be modeled with this relationship here. So what we have is, this is called the vertical motion model, and we're going to look at the height at different times. So it's like saying f of x, so you can think of it as like f of x. Over here, it's that idea. H stands for the height. And the time here is going to be measured in seconds. So I'll put that t, it stands for the time in seconds. So here's the equation that we're going to use here. It's negative 16 times t squared plus vt plus s. Now I need to explain what some of these letters mean. So t is your time in seconds. So that shows up a couple of times in the equation over here, the formula. Negative 16 accounts for acceleration due to gravity. Okay, so that's what that is. That will always be there. That's a constant that you will always see as your a value. It's what's in front of your t squared in this case. Now v, we need to talk about this. V is going to stand for your initial velocity. So we've talked about the word initial before. Initials come at the beginning of your name. Well, the initial velocity is how hard you throw the object to begin with. So if you're throwing something up, then it would have a positive initial velocity. If I can throw with a speed of, say, like, I don't know, 20 feet per second, I would have a 20 for my V. If I throw something down, it would have a negative number there because I'm throwing it with force down, and down is negative. If I just drop something, like I'm not throwing it up or throwing it down, I'm just going to go boop and drop it, well, then that would be an initial velocity of 0 because it would start out not going up or down. I'm just going to drop it. Okay, so you'll see that in problems. And then S stands for initial position. Initial position. So you can think of it as an S for starting height. So where do you start from? Well, let's see. It depends on the situation. If you are playing golf, and you're going to look at the height of the ball over time, well, then it starts out on the ground. So that would be a height of 0. So you would put an S, you would replace that S with a 0. If you are playing baseball, you're going to hit it about 3 feet probably up in the air. So you'd have a starting height of about 3. If you are jumping off of a 20-foot dive, well, then your starting position is 20 feet up in the air because you start from there and then you go up a tiny bit and then really far down. So that initial height will affect how long you're in the air and things like that. So this is the vertical motion model. So next I have a little video clip that I want you to watch, and we're going to see if we can figure some stuff out from this little movie clip. So watch this next.